Want to boost your web app's performance and reduce bandwidth usage? Understanding how ETag and Cache-Control headers work is the key. In this video, we'll dive deep into these powerful HTTP caching mechanisms that modern browsers and servers use to improve speed, efficiency, and user experience. What is an ETag? Definition. An ETag entity tag is a unique identifier assigned by the web server to a specific version of a resource, like a CSS file, image, or HTML page. How it works. A browser requests a resource. get/style.css http/1.1. The server responds with http/1.1200 OK. Content type, text/CSS. ETag version 1.2.3. The browser stores the content along with the ETag value. Next time, it makes a conditional request. get/style.css http/1.1. If none match, version 1.2.3. If the resource has not changed, the server replies with http/1.1304 not modified. No need to resend the file. Saves bandwidth. Benefits. Efficient cache validation. Reduces redundant downloads. Enables smart caching without relying on guesswork. Considerations. ETags can vary across servers, e.g., due to timestamp or node differences, which may break caching on load-balanced systems. Use strong ETags based on content hash for reliability across servers. What is cache control? Definition. The cache-control HTTP header defines caching policies for browsers and intermediate caches, like CDNs or proxies. Key directives explained. Directive. Meaning. Max age equals seconds. Cache the resource for specified seconds, e.g., max age equals 3600 1 hour. No cache. Store the response but revalidate it with the server before reuse. No store. Don't store the response at all. Used for sensitive data like banking pages. Public. The response can be cached by any cache, browser, CDN, proxy. Private. The response is specific to a user and should only be cached by the browser. Must revalidate. After expiry, the cache must check with the server before reuse. Example. Cache control, public, max age equals 86400 must revalidate. Means. Resource can be cached by browser or CDN. Cache is valid for 1 day, 86,400 seconds. After that, the browser must revalidate it. ETag versus cache control. When to use what? Feature. ETag. Cache control. Purpose. Validate if resource changed. Control how long to cache. Mechanism. Version/hash comparison. Time-based expiration. Usage pattern. Conditional request 304. Prevent/allow caching. Optimization. Saves bandwidth. Controls freshness. Together. Using both makes your web app faster and smarter. ETag, ABC 123. Cache control, public, max age equals 600. The browser will cache the resource for 10 minutes. After 10 minutes, it uses the ETag to ask if the file changed. Real example, browser behavior. First request. get/app.js http/1.1. Server response. http/1.1200 OK. ETag, XYZ 456. Cache control, max age equals 3600. Browser caches app.js for 1 hour. After 1 hour, browser sends get/app.js http/1.1. If none match, XYZ 456. If unchanged, http/1.1304 not modified. No download, just confirmation. If changed, http/1.1200 OK. ETag, XYZ 789. New version is downloaded. Best practices. Use ETags if your content changes frequently but not on every request. Use cache control to optimize long-term caching, e.g., for static assets. For static assets like JS/CSS/images use Cache control, public, max age equals 315360000, immutable, along with version file names like appv1.2.3.js for dynamic or user-specific data use. Cache control, private, no store. Don't forget to like, share, and subscribe for more backend, frontend, and DevOps tips.